please join me in doing one little experiment. Are you ready?
Yeah.
Okay, so put your hands together and start rubbing like this. You can do it a little better. Faster. Come on. Yes, you can do it. Okay. Okay, now you can feel your hands. Can you feel a little bit warmer? Okay. And do you know why they are warm? Yes, it's because of friction. So when you're sliding your hands, it has to overcome a little bit of resistance, which is because of your skin. And that resistance is called friction. So more is the force and more is the velocity, more is the resistance. And that resistance, causes energy to dissipate in the form of heat. So whenever there is a more friction, there is more heat. But this heat could not be good for certain applications, or in fact, many applications. So the car that you drove today to come to this event, and if it is internal combustion driven car, 17% of the friction, the energy that goes into your engine is lost. And if it is some of those electric vehicle, then it reduces to 8.5%. The energy is lost just because of friction. Now you can think about how friction is affecting every day of your life. Now how about if I told you something like this is going to change the lubricant industry? So think about that, and we'll come back to that later. But friction is everywhere. And the friction is everywhere in the world that we live in. And we experience the friction, no matter what, which walk of life that we are in. And to reduce the friction, you use some kind of lubricants. It could be oil-based lubricants, or it could be a solid lubricants like a graphite, or it could be some thin films. And that helps to reduce the friction, and it's a huge industry. And if you see by 2025, it's going to be $86 billion. It's a huge industry. Now, think about this. If you consider all the mechanical systems in the world, on the planet, and which have the rotating, sliding, rolling motions, and somehow, if we can improve their performance just by 1.3%, then that will lead to saving about 173 million barrels of oil. And that is equal to about $12 billion. So just improvement in 1.3% gives you a $12 billion saving. And not to mention, how many barrels of oil that you are saving that otherwise going, into the environment. Because oil is used as a lubricant everywhere. So all over the world, the people are looking at finding a better lubricant that is not only going to be environmental friendly, but it will reduce friction, reduce wear, and it will be very cheap, and it will last longer. And there are millions and billions of dollars being spent in finding that perfect lubricant. At Argonne National Lab, we have a different approach. We look at the things at the fundamental level, down to the atomistic level, to see if we can change the things at the atomic level that will have impact at much larger scale, like macroscopic scale. In fact, there is a name for the branch of science which does precisely that, and that's called nanotechnology. In other words, science of tiny things. Now you may ask, how tiny is a tiny? And I think that can be explained by this beautiful picture of a family having, nice time on a sunny beach. So if you look carefully at this picture, you'll see the diameter of the sun is 1.4 billion meters. And then if you look at the height of a person is about, 2 meters. And then if you look at, the grain of the sand, and that varies between 500,000 nanometers to 1 mm, depending upon whether you are in Hawaii or in the Florida. So, and maybe you're using some kind of sunscreen lotion, and that contains titanium dioxide nanoparticles. about the size of 100 nanometers. And, the water in the ocean, the diameter of this water molecule is about 0.275 nanometers. Now you got some idea about the length scale. So the nanometer is a billionth of a meter, and at this nanoscale, things are completely weird. They don't look as if that you see it, and they behave completely different than we look at it. So because of such a small size, each has a much large surface area than a bulk, and that surface interacts with the environment, and that's why at such a tiny scale, the material behaves completely different, and that's called nanotechnology. Now, how this nanotechnology is helping us to build the better lubricants of the future. Now, you might have used this device at the elementary school. I'm not talking about Apple Pen here. This is a graphite pencil. And if you look at the tip apex of this graphite pencil, and then look at, for example, in comparison, the grain of sand, and then if you took it under the optical microscope and zoom it by 1,000 times, then you will see this beautiful structure of a nice layers of this graphite stacked together, so millions of these layers, and they are held together by very weak, forces, atomic force, and that's called van der Waals force. And when you're writing it, onto the paper, then just the friction between this pencil and a paper is enough to dislodge or to remove some of these, graphitic layers, and that's how you can write it. Now we can take a little more sophisticated technique, electron microscope that can, blow up even higher magnification, like 200,000 times, and then you see these beautiful atomic planes of the graphite separated by a distance 0.34 nanometers. Now, interesting thing happened in 2004. Two scientists from University of Manchester in UK were not only able to separate this one atom thin sheet of a graphite just by using Scotch tape. Of course, they had to do it many times. But they were able to measure its properties. And when they were able to measure the properties, they were amazed, because just one single sheet of this graphite has completely different properties than the bulk graphite. So in other words, if we consider this is a bulk graphite, like a parent material, and then let's consider this, one sheet of a graphite is a child graphite, then this child graphite is much smarter, much better than this parent. Makes sense, right? If I say this to my son, he would be like, duh. So anyway, they call this material graphene. And it has amazing properties. It's like 200 times stronger than steel. It's carry the heat 5 times better than copper. And it's one of the best conductor of electricity. These are the only 3 properties I'm telling you. There are many such properties that are much better than the bulk graphite. And because of this material actually got, these people got Nobel Prize in physics in 2010. And then later on, they found out that there are also other layered material that have kind of similar property, like molybdenum disulfide and so on. And in fact, that gives to the birth of a new branch of physics called physics of two-dimensional materials. So in this case, you have 2 dimensions. That means you have only surface, there is no bulk. So the electron going onto the surface will not see any obstruction. It will just, pass by. Whereas if that electron is in the bulk material, like 3-dimensional material, then it will be influenced by the other atoms around it. So we were looking at this graphene, which is fundamentally different, in terms of mechanical properties as compared to the graphite. And then what we saw is that in case of a graphite, when you use it as a lubricant between 2 sliding surfaces, it tends to agglomerate. And sometimes it even abrade the material. But in case of a graphene, which is just 2-dimensional material, it slides nicely like a deck of cards. And then it reduces the friction drastically, and also the wear. So what we have found is that this graphene is not only environmentally friendly, but it produces this 5 times less friction and 10,000 times lower wear. Isn't that amazing? I mean, it's already starting looking like an ideal lubricant. And most importantly, it works in humid air and dry air perfectly fine. There is no solid lubricant that can work in any kind of environment. So this was already a breakthrough. But we wanted to go one step beyond. I wanted to see, can we go to the fundamental limit? Can we reduce the friction and wear to near zero? And that's where we combine graphene with another cousin from the carbon family, diamond, but in the form of nanodiamonds. By the way, these nanodiamonds are produced in a very different way. You actually take the TNT explosives, wrap it around the graphite, and then throw it into the stainless steel chamber, and boom. And because of the very high pressure and temperature produced in the shock wave, the graphite turns into diamond. So when we combine this graphene and nanodiamond together, what we saw is the superlubricity. And that's where we saw the friction is going down to near zero. And that was very amazing to see that for the first time in the world, we were seeing the friction and wear down to zero at macroscopic scale. Now, how does that happen? And remember this picture that you have seen before. Is what you're looking at is the brown ball is a nanodiamond, and the green carpet-looking things is a graphene. And this graphene likes to wrap around and then scroll nicely and form this kind of very nice nanoscale ball bearing. And this nanoscale ball bearing, you can imagine, they are sliding onto the surface, millions of those, and reducing friction and wear. So that was the most fundamental breakthrough that we have seen that can be used anywhere there is oil. And once you replace the oil with this nice lubricant, of course you have to use it in a dry environment, but if you're getting a low friction and low wear down to zero, it's completely possible. Now the breakthroughs like this really changes our thinking, and it's very important that those breakthroughs doesn't remain in the lab, but go outside. And that's how we started collaborating with the industry to see how this technology could be commercialized further. And in this case, in case of oil and gas industries, what we have seen is that the oil is extracted from the deep inside the ocean floor, and then the oil and natural gas, when they drill inside very much deeper length, then it has very high pressure and temperature. So you need a seal. There's a device called mechanical seals that protects the release or the leakage of the gases into the environment. And if you look at the total release of greenhouse gases into the environment, just in the US alone, is about 2 million metric tons. And that's a big staggering number. So with this solid lubrication technology, we believe that this could be reduced further and then can increase the lifespan of this lubricants technology to use it even for further use and make this kind of platform safer. Now in case of this metal stamping industry, and this is also used in making your car chassis. In fact, every industry has to go through this process to make your car chassis, and it happens generally at a higher temperature. So there's a metal stamping that happens, and in case of a friction, that produces a weaker point, and that's really directly affects the safety of the passenger in case of an accident or impact. So here also we believe that use of this solid lubrication technology will improve the performance, will reduce the friction, and will affect directly improving the safety of the passenger, as well as improving the production capability at a much lower cost. Another example is really in wind turbine technology. And one of the problems in this case is really to change these kind of bearings, which are mostly oil lubricated. And the lifetime of this oil lubricated bearing is a problem. So whenever there is a problem with this bearing, you have to completely revamp this, and there is a huge amount of efforts and money involved. So by using this solid lubrication technology, we think that it will not only increase the lifespan of this bearing, but also reduce the cost and will improve the efficiency. So disruptive technologies change the world. And in this case, what we have seen is that the lubricant industry is poised to take a next giant leap into the future that will change the course of the lubricant industry forever. Most importantly, these lubricants will be green lubricants and will also help to keep our planet cleaner and safer. Thank you.